Welcome to the world of relativistic mechanics. Yes, this video is about LIGO or detection of gravitational waves. Both are same. Whenever the term LIGO is used, that means it is being used for detecting the gravitational waves. You know, according to Einstein's general theory of relativity, in the presence of massive objects, there is a warping of space-time. That is known fact. Okay, and this we got from the theory of general theory of relativity of Einstein. And Einstein also predicted from his mathematical equations, he predicted about the gravitational waves. But at that time, there was no technology available to detect such waves because such waves are very subtle. That's why that time technology was not sufficient. Okay, means efficient technology was not available there at that time to detect such subtle waves. But almost after 100 years, the day is 14 September 2015, by using LIGO. LIGO means Laser Interferometer Gravitational Wave Observatory. That is the full form of LIGO, L-I-G-O, LIGO. Okay, that is the full form of LIGO. Laser Interferometer Gravitational Wave Observatory. So a group of scientists began to work with LIGO. Okay, first they made LIGO. This was made just to detect gravitational waves. So two black holes were merging at a distance of 1.3 billion light years from Earth. 1.3 billion light years, billion, okay. So during black hole merging, according to Einstein's general theory of relativity, they must emit gravitational waves. Okay, that is the prediction of Einstein. And you know that black holes are not visible because they do not emit light. No electromagnetic waves are radiated by black holes. So that is not actually visible. Black holes are not visible to our eyes or to our instruments directly. So, and if you can detect gravitational waves, then that is one of the ways to detect those things which do not emit any electromagnetic waves. And the group of scientists were successful. And they got their success on 14th September 2015. They detected light gravitational waves. Okay, in LIGO experimental setup, they used two L-shaped detectors. And length of each arm was about 4 kilometers. And you know, when gravitational wave passes through a space-time, according to the theory, there is a compression or expansion of the space-time. That means there is a distortion of the space-time, but the amount is very small. That amount can be compared with the fractions of the size of a proton. Very small, okay. Very small change is there, very small distortion is there. Whether it is compression or expansion, that means distortion. But the amount involved is very small. So in a LIGO setup, two arms were used, detectors actually, okay. Length of those detectors were 4 kilometers, and the scientists found experimentally a small change. When a gravitational wave passed through the detectors, they found a small change in the distance between those two detectors. Though the amount involved was very small, but that was precisely measured. That was precisely measured. Scientists are confident about this, about their findings. Okay, so that way gravitational waves were discovered for the first time. And this technique opened a new window into the world of technology, into the world of understanding the universe. Okay, it's a new window because by using this technology, we can detect other black holes collision or black hole mergers, when neutron stars are merging. Many stars are there, many phenomena are occurring in the universe. Maybe many of them are emitting electromagnetic waves, but since they are also emitting gravitational waves, and you know that gravitational wave memory is there. So by studying all those things, we can know about the Big Bang. We can know about the reality of the universe. We can know about many things about the black holes, because black holes are still not fully understood. So many cosmic phenomena can be known fully or in depth by using this new technology or by new discovery. What is the discovery? Detection of gravitational waves. That is the discovery. Okay, so this was all about today's topic. Okay, so this is the end of this video. Thank you for watching this video.